My name is Nick Muhammad Asri bin Nick Nahuddin. Today I'm going to talk about the biodegradable polylactic acid plastic which can be replacing petroleum-based plastic. So what is polylactic acid? Polylactic acid is made from fermented plant starch such as from corn, cassava, sugarcane, or sugar beet pulp. Polylactic acid or PLA's popularity increases since it uses renewable source in its production. Well, its backbone formula is C3H4O2. Okay. So the important question is, how does polylactic acid been made? Well, PLA is a polyester produced under controlled condition of a carbohydrate source like corn or sugarcane. Okay, its main building blocks can either be lactic acid or lactide monomers, which later will be polymerized into PLA. So this is how we do it. First, the corn goes through wet milling. Okay, here is where the starch gets separated. Okay, then starch is then mixed with acid or enzymes and heated. This process breaks starch into dextrose or corn sugar. Finally, fermentation of glucose produces L-lactic acid, which will be the basic constituent of PLA. Okay. The two methods for manufacturing PLA plastic from lactic acids are: the first one, use lactic as an intermediate state which results in greater molecular weight. The second method consists in the direct polymerization of lactic acid. Okay. After this, we want to talk about the advantage of polylactic acid against petroleum-based plastic. Okay. So PLA is bio-based and biodegradable. So since it's bio-based and biodegradable, these are the most outstanding properties, especially considering that one does not automatically imply the other. Being bio-based implies that the material is derived from biomass. As for being biodegradable, PLA undergoes a transformation into natural materials such as water, carbon dioxide, and composite. Okay, the process is carried out by microorganisms in the environment and is strongly dependent on conditions such as temperature and humidity. Okay, after that, PLA is thermoplastic, meaning that it can melt and reshape it without significantly degrading its mechanical properties. It is also derived from a renewable resource, a sharp contrast to the petroleum-based plastic which have a finite availability. After that, it is also close to the carbon natural, where its renewable sources actually absorb carbon rather than release carbon. It does not release toxic fumes when oxygenated. Besides that, it has economic potential. Bioplastics offer a growing market with opportunities for job creation and development of rural areas. It is estimated that by 2030, there will be up to 300,000 highly skilled jobs will be created in the European bio market, more than 10 times its current numbers. Okay. After that, the thermal and mechanical properties of polylactic acid. Well, the mechanical properties. PLA plastic has good mechanical properties compares to traditional polymers, okay, such as polypropylene, polystyrene, polyurethane, especially when it comes to young modulus, which is the ability to tolerate elongation under tension or compression, tensile strength, which is the force needed to pull something, and flexural strength, which is the stress needed to start plastic deformation. PLA also can be classified as semi-crystalline polymer. Its glass transition temperature at 55 degrees Celsius and melting temperature at 180 degrees Celsius, which are comparatively low. Which, as an example, when thinking of other thermoplastics such as ABS, and just like oil-based plastic, PLA can burn. The usage of polylactic acid. Okay, the first one is food packing industry. Okay, although the PLA is generally recognized as safe when using to store food, even though it can release lactic acid in contact with specific liquid, it was not found to have a concentration high enough to harm humans. After that, it is used also in healthcare and medical industry. It is used to make many kind of biomedical and clinical applications, such as in bone fixation device such as screw, plates, surgical structure, and meshes and drug delivery system. The structural applications. PLA material can be used in construction industry, as for example foam for insulation. But however, it is restricted to only some things and not all, because it is not ready to be proven yet. Okay. In textile industry also, many company has changed to polylactic acid since it has many properties such as breathable, lightweight, and it can be recyclability. Okay. The degradation of polylactic acid. PLA is degraded abiotically by three mechanisms, which is hydrolysis, thermal degradation, and also photodegradation. Okay. It can be decomposed by some bacteria such as Amycolatopsis and Saccharotix. Purified proteins can also degrade PLA, such as Amycolatopsis and also PLA depolymerase. Enzymes that degrade PLA, such as pronase and most effectively proteinase K from tritirakome. Okay, that's all for me. Thank you.